Hello friends, welcome back for another machine learning project, credit score prediction using linear regression. Here we will predict the credit score of an applicant using the model built through linear regression. So let's discuss first about linear regression. So for that, let's open the notepad where we will discuss about linear regression. So here you can see already title given linear regression. So linear regression is one of the simplest and most commonly used statistical and machine learning technique. It models the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. It is the simplest and most commonly used statistical and machine learning technique, and it models relationship between dependent variable y and one or more independent variables x. So models linear relationship between a dependent variable, nothing but y, and one or more independent variable that is x. So this linear equation can be used for two types of problems. One is for simple linear equation where we will predict only the target variable using one feature, that is 1x, and in case of multiple linear regression we will use multiple features, that is many x. So let me write that so that you can understand it better. So in simple linear equation we will have y equals to beta 0 plus beta 1x plus epsilon. So for beta 0 let us write c, and for beta 1 let us write m, then x, and for error term let's write e. So here c is nothing but the intercept, m is the slope also called coefficients, and e is the error term. This is the simple linear equation from which we use an independent variable x to find out the y, that is target. In multiple linear equation we will have y equal to c plus m1 x1 plus m2 x2 plus e. So here y is the target, c is the intercept, m1 to up to mnxn, these are coefficients of x1 x2 till xn respectively, and e is the error term. So this x1 x2 are nothing but the features in a data set or data frame, and the features are nothing but the columns. So do not be confused what is this x1. X1s are features or columns that we will use to predict the target, that is y. That is the simple or multiple linear equation, and we will use mean square error to reduce the error from this linear regression and update the c, that is intercepts and coefficients. For this linear regression we have some assumptions, like first one is linearity. The model assumes that the relationship between the features and the target is linear. It assumes relationship between x and y is linear. And the second assumption is that each row is independent of each other. This is for all models that we will study. So each sample means nothing but a row present in a data frame or data set. This is the second assumption. And in third assumption we are assuming that the errors variance is constant, and the terminology used for that is homoscedasticity. This means constant variance of errors we will get in our problem. And the fourth assumption is that errors are normally distributed. And the term for that is normality. So we are assuming errors are normally distributed. And the last assumption is that there is no multicollinearity. This means that all independent variables x1 to xn are not highly correlated among each other. These are some assumptions that we follow in linear regression, and let's discuss on the advantages and disadvantages. The first advantage is that it is very simple and interpretable. The second advantage is that it is very fast and computationally efficient. And the third advantage is that it is a very good baseline model. It means that this model is the approach from where the machine learning starts. So that's why it is called a very good baseline model. Similar to advantages, we have some disadvantages. The first one is that as this is assuming linearity and no multi-collinearity, we will face some problems, that is limited modeling power. Why? Because for non-linear cases we can't use this linear regression, and for collinear variables we can't use this linear regression. And the second disadvantage is that it is sensitive to outliers. And the third disadvantage is that it overfits in high dimensional cases. These are some disadvantages. So as this has many disadvantages, so extending this model to a better approach where we will apply some regularizations, where we will apply some penalties to make it better. So similar way, two more extensions are available. One is ridge, another is lasso. So extensions of this linear regression is ridge and the second one is lasso. Ridge adds L2 regularization to penalize large coefficients, while lasso adds L1 regularization for feature selection. So do not be worried about this. We will discuss more on ridge in some other videos. So these are some of the information on the topic linear regression. So I hope you understood what linear regression and what are its assumptions, what are its disadvantages and advantages, and what are the extensions from this are made. So let's move to the implementation part. So I am going to the Kaggle notebook where we are implementing a credit score prediction system with linear regression. For that we are using a dataset available in the Kaggle dataset platform, and through this input button I have added this credit card score dataset where we have a CSV file, bank loans underscore with underscores dot CSV. So using this CSV dataset file, I am developing the credit score prediction system with the linear regression machine learning approach. So before implementing, we are importing certain libraries required for building the model. So at first, importing the pandas to perform data manipulation with the CSV file or data frame, then importing NumPy to do numerical calculations with data, and importing job_lib to save the trained model so that we can use it for inference. Then from the library scikit-learn, we are importing the linear regression to implement the linear regression, and it is available in the module linear_model of scikit-learn library. Similarly, we are importing train test split from scikit-learn library to split the dataset into train and test. Then we are importing column transformer from scikit-learn. It is a class which we can use to pre-process all the features simultaneously. To pre-process all the features simultaneously, we will use column transformer. Then we are importing the pipeline to create a pipeline between preprocessor and the model, so that we can feed the raw values to the column transformer, which will pre-process the raw values, then returns the processed values, which we will feed to our model. And to do that, we need pipeline. Then we are importing min max scalar and standard scalars to pre-processing utilities. These pre-processing utilities are used to pre-process the numerical items. I always use min max scalar for floating point d types, and I use standard scalar for integer d types. So the min max scalar will scale the values of the column in the range of minimum to the maximum values present in the column, while the standard scalar will scales down the values present in the column to -1 to 1. So let's import. After importing, using the read CSV method available in the pandas library, we are reading the CSV file located in this location. So you can copy it by clicking on this button, copy file path, and I have copied that and pasted over here. After that, using head method applied to the data frame, we can see the first 3 rows or 3 samples. So let's run. So here you can see we have the first 3 rows with the column names like age, education, employee, address, income, debit, credit debt, other debt, default, credit, score. So these are the columns we are having. So for that, first of all, I am renaming the column so that we can understand it better. Here I have renamed certain columns only which are required to rename. I am leaving age and education because these are meaningful, while the employee does not gives a proper meaning. So employee column has the values of number of years employed by the applicant. For that I am using n years employed, and then for the address column it gives the values of number of years in that address by the applicant. So I am using n years in address, and for income I am leaving as it is. For debit income, it is nothing but the debit to income ratio, and credit debit is nothing but credit to debit ratio, and other debt is nothing but other debits from the bank account. And then we have a column default. It is nothing but the defaulted loan, whether the applicant previously defaulted a loan or not. So it has the values between 0 and 1, not between 0 and 1, either 0 or 1. If he or she is defaulted, then that is 1, else 0. Then we have credit score. So let's rename. So here we have renamed all the columns. After that, using drop duplicates method, we will remove the duplicates if available, and inside that method we have passed two arguments, in place equal to true, that means it will change the original data frame. Then ignore index equal to true, that means indexes will be reordered. Similarly, using the drop NA method, we will remove the null values if they are present in our data frame, and we are passing the same arguments, in place equal to true and ignore index equal to true, so that original data frame will be changed and indexes will be reordered respectively. Then we are going through the information about the data frame. So here you can see we have 7000 entries where range index starts from 0 to 699, and these are the names of the columns, and this is the count of null values and their d types. So here you can see we have 5 float 64 columns and 5 int 64 columns. After this, I am splitting the data into train and test. So using train test split method, we are passing the x and y. X is nothing but all the features, that is independent features or variables, and y is our target, that is our credit score. So in X we are dropping the credit score column, and in Y we are having only the credit score column. Then we have an argument test size equal to 0.15 in train test split. It will pick out 15% of the data randomly to test samples. Then we have an argument random state equal to 42, so that whenever we rerun the notebook, it will return us the same data as it is returning now. So let's see the shape of X train and Y train. So you can see we have 595 samples 509 features in X train, and in Y train we have 509 samples with one feature, that is credit score. After that I am doing pre-processing of the raw data using a column transformer. So to pre-process the raw data, we will build the column transformer and name it city as an identifier. So in column transformer class we need to provide transformers an argument which takes list of tuples, and in each tuple inside the list we have to provide three things. One is the identifier, another is the pre-processing utility, and the third one is a list of features. So as we are using min max scalar and standard scalars, so we have the identifier min max scalar, then the min max scalar utility, then the features list. So we will be applying min max scaling to age, n years employed, n years in address, and income. We are applying standard scalar to debt to income ratio, credit to debit ratio, and other debit. So here for D type integer I am using min max scalar, but usually I use it for float D types, and here I am using standard scalar for floating points, but I usually use it for integers. And then remainder equals to pass through, it is an argument to the column transformer. So this argument will do not changes anything if the values or features are not mentioned in the tuples of the transformer, and it takes two variables. One is drop, it takes two values, one is drop, another is pass through. When we pass drop, it will drop the features which are not in these lists, and it will do nothing if we have the value pass through. Then we have an argument sparse threshold equal to 0. This argument will be used to return the sparse data generated through the column transformer. So when we give the value 0, it won't return any sparse data, and the value it takes is in the range between 0 to 1. 1 means fully sparse data, 0 means no sparse data, and in between 0 and 1 means partial sparse data. So let's see the column transformer. So here you can see we have two pre-processing utilities, min max scalar and standard scalar, and for other features we are just passing. After that we will build a linear regression model. So here you can see we are constructing a pipeline using the pipeline method, where we need to provide a list of tuples again in the argument steps. So here in this tuple we need to provide an argument and the method which we will be using for doing that task. So we are having only two things. One is a preprocessor, another is the linear regression model. So in tuples we are having only those two. So let's see this pipeline and let's see this model. So here you can see from all these pre-processing utilities, after pre-processing we are passing that data to the linear regression model. So let's train the model with the trained data. So in scikit-learn we have a fit method which we can apply to the model to train the model. So let's run it and train. So the model is trained very quickly. That's what an advantages. So I have already told that in advantages case that it is very fast and computationally efficient. Let's evaluate the model. So for evaluating the model we will be using mean square error. So let's see the score with the test data. So here you can see the accuracy is 1 to the test data. So let's save the model with the job libs method dump, where we need to provide at least two things. One is the model, another is the identifier or the file name. So the model is successfully saved in the credit score predictor .joblib file. Then let's save the data frame for future use, and this data frame is the cleaned data frame, and we are saving that in the credit underscores .csv file. So after saving these two things, you can download them from this output section. Click over this triangular item. So here you can see we have credit score predictor.joblib and credit scores.csv. Click on three dots to download both of these files. So up to this we have implemented the credit score prediction system through the linear regression model. Now we will build an interface to use this linear regression model for credit score prediction. So let's move to the VS Code editor. Here I have created a simple interface for using that model. So first of all, we have downloaded that file path where the model is present and the data file which we will use, and also a simple video to make the interface attractive. So let's discuss how we have developed this. Using Streamlit we will develop it. So first of all, I have imported Streamlit, which we will use for building the interface. Then pandas and numpy as usual. Then joblib is to load the joblib file where we have our linear regression trained model. After that, using the load method available in joblib, we are loading the model and saving it in the variable model, and then loading the credit scores csv file to the df, that is data frame variable. Then first of all we are showing a video using the video method available in Streamlit under the container. So it will autoplay and it is muted and it is looped. Then we have a container for inputs where we will have 9 columns, and under 9 columns we have 9 features. So the first feature is age, where we have to provide the value between the minimum and maximum of the values present in that column, and the default value is as the minimum value, and it is converted to integer 64 because we will receive a string type, then we need to convert to integer 64. And make sure that you should always be converting the data to the required data type. And in education feature, we are providing options to select, and it is also converted to integer 64. In number of years employed, we are doing the same as and converting to int 64. Similarly, we are doing for number of years in address and number of income. Then to debit to income ratio, credit to debit ratio, other debit and default loan, we are converting them to float 64 D type. After that, using the data frame, we are converting it to a data, and make sure that whenever you are doing or building this type of interface, you should always need to provide the data in a list so that you won't get any errors. So after that, using that data, that raw data, and with the predict method applied to the model, we are generating the prediction for these data given by the user, and then showing the credit score of the user. So guys, here our project is completed, but don't worry about the notebook or the app.py file where Streamlit is used to create the interface. Don't worry about these things, and also don't worry about the credit score.csv file. So after this, let's run this file and see the output. So to run this app.py, we need to enter Streamlit run app.py and hit enter. So you will be redirected to the default browser. So here you can see we have a video, check my credit score, where it is showing some numbers. Yes, the maximum is 800, it is shown. So when we are taking the default values, the credit score is 467. So we can change this. So here you can see the age should be between 20 to 56. So let's change the age to 35. Now the credit score is 473. And in education, we are having the range of education 1, 2, 3, 4 and 5. So let's take 5. So you can see the credit score is improved 476. Let's change the n years employed from 0 to some other values between 0 to 31. So that is number of years employed by the applicant. So we can take, let's say, 15 years. So you can see again the credit score is improved to 482. Then the number of years in the address resided by the applicant, so it should be between 0 to 34, let's say 10 years. So you can see the credit score is 486 now. Now if the income is 14, it is 486 only, and the income has the range of 14 to 446. Let's change the income to 250. So you can see there is a boost in credit score, that is 627. Similarly, the debit to income ratio range is from 0.4 to 41.3. let's say we have the ratio of 1.2, so it has not impacted more. Let's see the credit to debit ratio. So it is having a range between 0.01 to 20.56. so let's enter some value between, let's enter 2. So the credit score is 626. Now let's change the other debits also, and it has the range 0.04 to 27. Let's enter 5. So the credit score is 625, and the defaulted loan is either 0 or 1. So you can choose between 0 or 1. So when we are choosing 1, it is returning 624 as credit score, and choosing 0.0, it is 625. So when we change the income, the credit score will change again. Let's say we will have 430 as our income. So you can see there is a boost in credit score, that is 733. So this is the credit score checking system, and anyone can check this credit score if they have the age, education level, number of years employed, number of years residing in the address, income, debit to income ratio, credit to debit ratio, other debits, and whether they have defaulted loan or not. Thank you very much for patiently listening. Thanks a lot.